Have you ever gotten a super robotic email back from an AI? Or maybe a completely uninspired, boring brainstorming list, and you just think to yourself, well, I guess the technology just isn't quite there yet. Well, the truth is, whether you're building an entire AI app from scratch, or you're just trying to get a better response out of ChatGPT or Claude, there's actually a hidden setting behind the scenes pulling all the strings. It's a single number, and it's called temperature. And honestly, mastering it completely changes the game, because it allows you to tune the machine to your exact needs. But before we even get into how it all works, we have to address this massive rumor floating around forums and prompt engineering circles. There is this huge misconception out there, especially among newer developers and power users, that adjusting this mysterious setting somehow boosts the AI's underlying intelligence. People will literally whisper that if you just dial this parameter to some magic number, the AI suddenly unlocks this hidden genius level, allowing it to solve complex math problems that it couldn't solve before. Yeah, that is completely false. Changing the temperature does not alter the AI's IQ by even a single point. It doesn't give the model new knowledge, it doesn't give it access to secret databases, and it definitely doesn't miraculously upgrade its logical reasoning skills. A model with a temperature of 0 is exactly as intelligent as a model with a temperature of 1. So, that sets up the central mystery for our explainer today. If this famous dial doesn't actually control intelligence, what exactly is it controlling, and why does changing it so radically alter the answers you get? To find out, we really need to peek under the hood. Section 1. Inside the AI's mind. Okay, let's dive into this. To understand temperature, we first have to understand how an AI actually writes. You might think it generates a whole paragraph all at once, but it doesn't at all. It's much more like a storyteller sitting by a campfire, meticulously choosing their very next word based entirely on the story they've told so far. The AI's thought process happens in 4 distinct steps. First is tokenization, where it breaks down your prompt into these tiny puzzle pieces of words or syllables called tokens. Second is Logits calculation, where it scores every possible word it knows to follow your prompt. Third is Softmax activation, which turns those raw scores into percentages. And finally, token selection, where it actually picks the winning word. The magic, and where temperature actually lives, happens right in the middle of this exact sequence. Let's look really closely at step 2, the Logits. Imagine the AI has a massive bag containing hundreds of thousands of heavily weighted dice, literally one for every single word or syllable in the English language. When it needs to pick the next word, it assigns a raw score, which is called a Logit, to every single die based on billions of pages of training data. Let's make this concrete. If your prompt is, the sky is, the AI's die for the word blue is heavily weighted, earning a massive raw Logit score of, say, 2.5. Meanwhile, the die for the word pineapple gets a massive negative score, because, well, those words rarely go together. But at this stage, these are just raw, messy, abstract numbers. They aren't probabilities. That's when a mathematical formula called softmax takes over to convert those raw, messy scores into a clean probability distribution that perfectly adds up to 100%. The highly weighted words get these massive probability spikes, while the unlikely words share just a tiny, tiny fraction of a percent. Left entirely to its own devices, the AI will naturally use a process called greedy decoding. That's where it repetitively picks the number one highest probability word, every single time. But did you know that if an AI only used greedy decoding, it could easily get trapped in an infinite loop, just repeating the exact same sentence forever? It's highly predictable, sure, but it's fundamentally broken for engaging human conversation. Which leads us to a pretty surprising question. What if you don't want the exact same boring robotic answer every single time you hit enter? If the AI always takes the absolute safest, most probable route, it writes like a dry, overly cautious textbook. It lacks human flair, it lacks creativity. It completely lacks that spark of the unexpected. If we want an AI that can brainstorm, write poetry, or just sound human, we need a mechanism to deliberately inject a little bit of controlled chaos into the machine. Section 2. The Dial of Chaos. Enter the temperature dial. This is the ultimate mathematical solution to that repetition problem, and the name actually comes directly from statistical mechanics and thermodynamics. Think about physics for a second. When you raise the temperature of water, the molecules gain kinetic energy and bounce around chaotically into steam, right? When you lower it, they freeze into predictable, rigid, highly structured ice. AI temperature does the exact same thing to language. Mathematically, it is beautifully simple. Temperature is just a number that divides the raw logits before they become percentages. If you divide by a tiny fraction, the gaps between the word scores explode and widen. If you divide by a large number, the gaps compress and the scores flatten out. You are mathematically altering how adventurous the AI is allowed to be. Let's actually see this controlled chaos in action. Imagine we set a very low temperature, say zero point 0.2. By dividing the raw scores by a number smaller than 1, the math radically widens the gap between the top score and all the bottom scores. The probability distribution is massively sharpened. The top choice becomes a near mathematical certainty, basically freezing the AI into solid ice. Let's look at a practical demonstration. If we ask the AI to write a poem about a cat at a temperature of 0.2, it'll probably output something like, "The cat sat on the mat. It was a good cat." It is locked in, highly focused, incredibly cautious, and totally predictable. Let's move to the opposite extreme. If we set the temperature incredibly high, say to 2.0, we're dividing the raw scores by a much larger number. This compresses and shrinks the gaps between the scores. The probability curve flattens completely out. Suddenly, the safe, predictable words lose their dominant advantage, and weird, highly unlikely words are given a legitimate fighting chance to be randomly selected. Now, run that exact same write a poem about a cat prompt at a temperature of 2.0. Because those probability gaps have shrunk, the AI might output, "Feline shadows dance on lunar crusts, whispering pizza dreams to the void." The AI has completely thawed out. The linguistic molecules are bouncing absolutely everywhere. But this raises another really fascinating question. Why does setting the dial all the way up to 2.0 make the AI sound like it's had way too much coffee? Well, when the probability curve flattens completely, the AI is essentially forced to start picking words from the absolute bottom of the barrel. It's exactly like putting your Spotify on shuffle, but instead of just your favorite genre, the algorithm is forced to randomly pick from literally every audio file on Earth, including, a 1920s vacuum cleaner sound effect or a random lecture on dentistry. The AI starts connected concepts that simply shouldn't be connected, and this is precisely where AI hallucinations and total grammatical breakdowns happen. Section 3. Mastering the controls. So, knowing that the dial controls this super delicate balance between rigid ice and chaotic steam, how do we actually use it day to day? Well, this is your golden cheat sheet. If you're asking the AI to write software code, extract data from a document, or do math, set the temperature to 0. Why? Because a single hallucinated comma or a wildly creative variable name will instantly break your entire application. You want the cautious textbook. Now, if you want a helpful conversational chatbot or a summarizer, 0.7 is really the sweet spot. A temperature of 1.0 is the standard default for most models. It's absolutely perfect for marketers brainstorming slogans or creative writers looking for a spark. And if you're generating avant-garde poetry or just want to see something totally wild, push it up to 1.5. But just when you think you've completely mastered the machine, you open your AI developer dashboard and you see another dial staring right back at you. You might be thinking, wait a second, what about that other mysterious setting sitting right next to temperature called top P? This is a sibling parameter that endlessly confuses prompt engineers, tinkerers, and developers alike. And it's absolutely essential we clear up how it fits into the whole puzzle. Section 4. Temperature versus top P. Both settings solve the repetition problem, but they do it from entirely different angles. Think of the AI's vast vocabulary as a crowded nightclub. Temperature, as we've learned, turns up the heat and gives everyone in the entire club an equal chance to hit the dance floor, fundamentally changing the shape of the whole room. Top P, which is actually known in research as nucleus sampling, acts a lot more like a strict bouncer at the door. If you set top P to 0.9, the bouncer looks at the bottom 10% of the absolute weirdest, worst, most nonsensical words in the dictionary and kicks them out into the alley entirely. They aren't even allowed in the building. Then, temperature controls how wildly the remaining 90% are allowed to dance. Now, because these two settings interact with the exact same underlying token selection process, there is a golden rule in the AI industry. Experiment with one dial at a time, but rarely both at the same time. Adjusting both simultaneously is like trying to steer a fast-moving car with two completely different steering wheels. If you look at the major players, OpenAI uses a combination of temperature and top P by default. Anthropic's Claude supports both as well. And Google's Gemini models actually support temperature, top P, and another highly specific variation called top K. The major takeaway here? Just stick to adjusting your temperature first until you get a true feel for how the model behaves. All right, here's one final surprising fact that often trips people up right as they start experimenting. Because a temperature of 1.0 is largely considered the baseline of average human-like creativity, a lot of users just assume the dial goes from 0 to 1, exactly like a standard percentage. But can the temperature actually go above 1.0? Yes, it totally can. On platforms like OpenAI, you can crank that dial all the way up to a staggering 2.0. But as we learned earlier about the completely flattened probability curve, if you go that high, you should really expect total unmitigated nonsense. The AI becomes so wildly adventurous that it will string together grammatically broken, incoherent sentences. If you ask a 2.0 model for advice on your day, you might get something weird like, "Banana calculus wept Tuesday under the refrigerator's glowing sigh." It's highly amusing for a 5-minute experiment, but completely terrible for getting any real work done.
The final reveal. Let's recap.
So, looking back at our investigative journey today, we started by busting the massive myth that temperature equals IQ. We journeyed through the math of tokens, logits, rolling like heavily weighted dice, and strict bouncers guarding the nightclub door. Which brings us to our final powerful realization. If you take away just one single thing from this explainer today, let it be this. Temperature doesn't change how intelligent AI is. It changes how adventurous it is when choosing its next word. You now have the knowledge to perfectly tune your AI outputs, whether you need cold, hard, predictable code or wildly adventurous brainstorming. But it leaves us with one final, slightly unsettling question. If true human creativity is often just connecting unlikely concepts, and AI temperature simply forces those unlikely connections using raw math, is human inspiration just a biological dice roll? Definitely something to think about the next time you sit down to write. Thanks for joining me on this explainer. See you next time.